Here I want to do a few examples illustrating the use of the limit of sine of x divided by x goes, where x goes to 0 is equal to 1. So the first one I'll try is sine of 2x over 24x. Now what I've got to have is when I say sine of theta over theta, I can't evaluate this limit right now because there's not a 2x in the denominator, there's a 24x. I've got to manufacture a 2x in the denominator. So that's easy enough. 24x is equal to 12 times 2x. Now the limit as x goes to 0 of the number 12 is just 12. So I can pull the 1 out of 12 out front of the limit and now do the limit as x goes to 0 of sine of 2x divided by 2x. So here I had the same quantity in the numerator and denominator going to 0. Therefore that particular limit is 1. And so you get 1 over 12. These are going to be quick examples, so let me do another example. It looks more complicated, but it really isn't. You're always trying to harken back to the limit as theta goes to 0 of sine of theta over theta. So let's try this one. The limit as x goes to 1, sine of x, no, minus 1, divided by x squared minus 1. Well, what I'm going to do is factor the x squared minus 1 into x minus 1 times x plus 1. So I have the limit as x goes to 1, sine of x minus 1 divided by x minus 1 times x plus 1. Now I can break this up into a product of limits according to that product rule. So I can write this as the limit as x goes to 1 of sine of x minus 1 divided by x minus 1 times the limit as x goes to 1 of 1 over x plus 1. Now the sine of x minus 1 over x minus 1, that x minus 1 is going to 0, so that limit is equal to 1. The other limit, I can just plug the 1 in for x, and I get 1 over 2. So 1 times 1/2 gives me 1/2. Moving on, another one that doesn't really look like it fits the pattern, but it really does. It's the limit as x goes to infinity. X times, no, I want an x times sine of 1 over x. Now notice 1 over x is going to go to 0 as x goes to infinity. So I'm going to rewrite this fraction. Oh, before that, let me warn you of something that students typically do. A lot of students will recognize that the limit of x is infinity and the limit of sine of x, sine of 1 over x is 0, and they'll write some stupid stuff like infinity times 0. No, don't play that game. That's an indeterminate form. There's nothing you can do with it. So, okay, with that warning in mind, the limit as x goes to infinity of x times sine of 1 over x. The trick I'm going to do is instead of have x in the up there with sine, I am going to put 1 over x in the denominator. This is a simple little algebra trick you ought to be familiar with. Now I have sine of something that is going to 0, and it's divided by the same quantity that's going to 0. See, the 1 over x goes to 0 as x goes to infinity. So if you look at this, this is no different than the limit of sine of theta over theta, where theta is going to 0. So this limit's just equal to 1. So you need to be able to do a little bit of algebraic fun for these problems, but also use the rules as needed.